Every day and every night, trains around the world carry people to the places where they belong. We at voestalpine Railway Systems understand the needs of global mobility. We maximize safety, improve efficiency, and take availability to a new level. Because we believe in railway transportation, the most sustainable mobility system to face urbanization and increasing levels of freight traffic. As the only global provider of complete track system solutions, we offer the most extensive and integrated track portfolio, rails, turnouts, signaling solutions and services. We build our success on 160 years of experience and with a continuous drive for improvement and innovation. The source of our success is us, the team of voestalpine Railway Systems. We are researchers, seeking for advanced materials and geometries. We are workers, creating rails and turnouts with state-of-the-art production systems. We are developers of smart solutions for the railway infrastructure of tomorrow. It is all of us who deliver track components just in time to any location. And it's us who offer a comprehensive service portfolio along the whole life cycle of our products. We develop the most innovative solutions with a focus on the organization of life cycle costs to keep our promise. We are more than 7,000 colleagues working at 70 locations on 5 continents, combining our knowledge, experience, and talents for the benefit of our customers. This is our contribution to modern mobility and a green planet worth living for future generations. This is us, the team of voestalpine Railway Systems. And together, we ensure performance on track.
voestalpine, one step ahead.
Good afternoon, everyone. Thank you for joining this very special webinar hosted by Railtech.com and voestalpine Signaling. I'm joined by Stefan Distlberger, Managing Director, CSO, Thomas Butz, Product Development, R&D. Thank you, gentlemen, for joining. We're going to be talking about the visual train analysis, short VTA. Thomas, we had a little chat earlier about the background. Today, you're going to be talking more in depth about the system, along with Thomas, going forward-looking, more details. Looking forward to that greatly. But I think you're going to start with a few questions for our online audience and to see where everyone's from, I believe, right?
Yeah, absolutely. Thank you, Nick. Thank you for being invited here today. The first questions that we had is, where are all the guys on the audience are dialing in right now? Because we're interested in, is it just Germany, is it Netherlands, or is it really worldwide? Maybe you could put in the chat where you are coming from. It would be interesting. I've also another question that I would like to follow up to is, would you rather buy hardware, or are you interested more in buying the information that comes maybe from the hardware? This is also a difficult question that is not yet answered to everybody. Maybe we can also expect some answers here.
Yeah, definitely.
And maybe we have already some experts on the webinar. So if you are an expert or you have experience in VTA analysis, maybe do you have already experience in this field? Maybe a yes or no. I think there will be a poll for that.
Yep, definitely.
And the last question is, if you can think about a specific use case you would use video analysis to monitor your trains, what would it be? So maybe we can start with this question.
We have people so far joining from the Netherlands, UK. Responses are still coming in. With regard to your first poll, perhaps this is good news for you. People would rather buy the hardware.
Ah, okay.
So it's a promising sign. More people from UK, Carinthia, your home country,
oh, wow.
coming in. And not a whole lot of experience yet with visual analysis. So I think your presentation comes at a timely moment. And it looks like our audience is quite keen on learning more about what this all entails. So gentlemen, let's get right into it. The VTA.
Let's start with the presentation. So we would like to start maybe with a small video to see how a checkpoint looks where we have a VTA installed. And I can lose some words here. So what you can see here is a gantry with our profile validation system where a branch of leaves penetrating the envelope, triggering an alarm. This is one of our wayside monitoring functions that we have. The train then continues its journey over our acoustic monitoring system, where we also get information from our bearings or from even wheel defects, if you want to look at that. The next system is the wheel defect detection and also weighing in motion system, which is heavily distributed, of course, in the Netherlands and worldwide. This system is called traction motor. Most of you will recognize the HBD, the hot bearing detection scanners on the left and right side of that. And now here is what we're talking about today, the visual train analysis system with the yellow pole in the middle and the flashes surrounding it. And what you can see here is examples like the USC number that gets pulled, rim thickness, or a QR code. And last but not least, also a drag equipment detection scanner that is hit by a very long chain. And also here is a camera, because you definitely want to know what hit the drag equipment detection and if it can harm your infrastructure. So if we go back on the slides and if we think about visual train analysis, the first question that we should ask is, why now? Why visual analysis of trains? And I would like to explain it by looking at our key visual of our wayside monitoring equipment. And what you can see is a lot of different functions that we have. For instance, we see the wild function here in the beginning, hotbox detection, and other functions like the acoustics, and in the far back, the profile validation system. And on the right side, you already see what was first initiated as the yellow cabinet was the VTA. So where did it come from, and why do we want to introduce that now? So there are several factors, of course. And one, I would like to start really at the early beginning, because when we started, and even before that, it was very important to have wayside monitoring equipment for alarming and intervention. The first thing that was introduced was the hotbox detection scanners, because obviously bearings, when they become very hot, it often triggered a catastrophic event like derailments. So this is the first thing that came, and then many more functions came over time. And we gradually shifted from alarming and intervention, which is really the immediate response that you have to do something, to a more condition-based and historical data-based event-driven functions, such as an acoustic bearing detection, where you want to know how does the bearing evolve over time. One of our founding members, he always compared it as going to the doctor. So when you go to the doctor looks at you, he maybe listens to you, and maybe touches a little, take your pulse, etc. So he uses its senses to get your health check. And this is the same way we see it, and this is why we have our strategy with our checkpoints, where we think that co-located, spatially and timely synchronized different functions can get an overall health check of your train. So this is basically where we come from. And what you see already on the left side, we already had a camera for our drag equipment detection, and we also had cameras for our profile validation system, because you want to know if something is sticking out, and you want to know if it's just a leaf that is not really that important, but it could be something more severe that could endanger your infrastructure, or even people on the terminal waiting if there is a wood standing out, whatever. So all of those functions are very specific, designed for use case. And a couple of years ago, we started to develop more use cases for the same functions. For instance, we look with HPDs also now at the motor, because also motor gets hot if something is not working, or a gearbox.
Yeah.
So this is what we call traction motor. You see at the beginning. And the use cases get more and more complex, because also our customers, and we see this worldwide, are more and more interested in getting condition information earlier, at an earlier stage, so that they get into maintenance shops earlier, that they know what to have to do, how long a train may go. And this is where we found our blind spot, and this was the visual train analysis, because now, if you think about it, 10 years ago, if you made a picture with your phone,
it was average.
It was average, yeah. So most people that wanted to have good quality pictures, they went around with a big DSLR camera. And nowadays, the pictures are brilliant. So the quality of the cameras and also the cost of the equipment has become very, very good. On the same side, we have new technologies like 5G. We have also the maturity of the data networks. The customers, they have the necessary bandwidth now to really utilize the strengths of a VTA system. And this is why we think now is a really good time to enter in that. And we cannot do this alone, because we always need the customer to give us the use cases, and so that we can explore together with the customer what is the use case, what is the problem you're trying to solve, and can we solve that by the use of an image? Because what you can see on the image, you can eventually measure and draw conclusions out of that. And we very much believe that this is the way forward, and this is why we have now introduced our visual train analysis.
Let's dive right in.
So where are we going with visual train analysis? And maybe, Thomas, you can elaborate on the functions.
Yes. So that's what Stefan said. The use cases we discovered together with our customer and out of tenders. Yeah, we looked at it, and one of the main use cases was the UIC number and OCR recognition. So what is written on a wagon or on a train? To discover that, we had use cases to discover hazard goods signs, to see what kind of loading is in it, information plates, QR codes, pictograms, to see them and show the customer that they are on it. Data matrix codes, revision numbers are also important. And for example, also container codes, containers on a wagon. To see it, there is an ISO norm about it. That was also something where the customer said, hey, can we recognize that? Yeah? We call it, that's our pattern recognition.
Right.
In slide number 2, I can show you shapes, forms, and additional functions. Yeah? So what is very important for us to know is the direction, how the train or the wagon is on the track. Yeah? So we need to read out with measurements how the train is located. We have a lot of things we can read out regarding brake, for example, brake lever position, or we look on top of the wagon, see the container fill level. Yeah. What is also heavily requested are panorama images, just to see what the status of the wagon is. Yeah. And of course, any doors on the wagon, yeah, are they open, are they closed? Yeah, that's something. Is there something damaged? Yeah, also something which a customer wants to see and wants to have recognized automatically via cam, so that some human can go to the wagon and check, oh, is it critical or not? Missing handbrakes, wheel detection, and the 2 down there are the dirt detection. Yeah. How dirty is the container? Sometimes you can't read the UIC number because there's dirt on it, or even worse, if there's graffiti on it, is a possibility to also recognize graffiti automatically and then give information to the customer. The next slide is the bogie inspection. That's something very special. Yeah, that's something also where we are not specialized in springs and brakes. And like Stefan said, together with the customer, we went in, we showed them the pictures and said, hey, listen, is it something, what do you want to recognize? And what is, show us pictures where it's broken, and then we can check if we can find an algorithm who then detects these kinds of things. So we have rim thickness, shoe thickness, wear profile, head detection, we have a sliding wheel. So we make 2 to 6 pictures from one wagon when it passes along the VTA. So we can check if the wheel is turning or not. It's a very seldom event, but it makes a lot of damage. Yeah. Then, of course, springs. Yeah, we have a look on the springs, everything what we can see from the outside. Yeah, spring height, spring spacing. If it's broken, a spring, we can detect. If it's missing, yeah. The same thing with everything around bearings. Screws missing, plates missing, caps missing. We can detect and give information to the customers that something is missing, and also a picture that a human being can check, okay, it's really missing or something which is critical or not. Yeah. Then we also try to detect the kind of bogie which is just passing, also critical information, for example, when we are located in a yard. Yeah. Last is the missing R-clip. It's a clip inside brakes, and if it's missing or if it's not on the right position, then it's something where you need to do something. Yeah? So these are all use cases we experience together with our customer. Right. And now some live pictures. Yeah, I'm showing you here the research site in Austria, where you can see our VTA installation. You don't see much when you look at the picture directly, but I will explain to you. You see on the left the gray cabinet. In this gray cabinet, we have the power for the cams and the flashes and everything. This goes to the track, and to the other direction, the data goes. We are using Gig E-Vision cameras, which are connected via Ethernet to a very powerful video PC, and all the camera recognition and filtering we do inside the cabinet to get the information as soon as possible. If you look here, you see that we are monitoring the right track, and you see we have cams which are far away on the left, we have cams in the middle, and we have cams on the right side. And even on top, 8 meters on top, there's a cam which is looking on the top, yeah, of the wagon. Yeah, on the right, this is inside the yellow box we just saw, right, and you'll see again. These are our 2 cams. We decided that we need one special cam for the bogie, because we need more details, I mean, we need more resolution for that. And we have one cam at the top for the rest of the wagon, where we also do the UIC number recognition. So it's quite flexible. If you only want to have the UIC number recognition, you only have one cam, yeah. And if you want more, like this is everything, yeah. That's a full build, and you have more cams installed. Okay. So that's an architecture view on our VTA system. You see in these yellow boxes, there is a pole inside and 2 cams. You can slide them up and down to get into the right position. We have a lot of flashes. You see there are 8 flashes. It's not always necessary to have all these flashes. It also depends on the use case, what you want to see. Yeah, we have some pictures later, Stefan will show, where you see the different lights.
So this is not in any way a standard setup,
no,
right?
that's not a standard setup. That's only to show there is, you at least need one pole with one cam, and you at least need one flash. And then the data flows into the gray cabinet. Now we see the gray cabinets open from the front, and inside the gray cabinets there is a very powerful video PC which does all the processing, makes messages, and creates pictures. Yeah? Small ones, big ones, everything we need in our central management software, CMS software, where usually the user logs to. So the CMS is usually located in an IT environment at the customer. It's one system where all the information is sent. And with the software, you can see the messages, and you can see the related pictures to the messages from the VTA and from all other systems which are installed. Yeah? Of course, it's possible also for us to make interfaces into our CMS to send the data to additional systems the customer uses for managing the train yard, for example. Yeah? Okay? Yeah, one step deeper. So what we are using on hardware? So we have cameras, we have lenses, and we have flashes, and we have this video PC. What we are using are cameras, near-infrared cameras, very high powerful, with a CMOS sensor. We are making, because we are using infrared, black and white pictures with a resolution of full HD. You can see there 2048 to 1088 pixels. We decided quite soon at the beginning that we want to use infrared, because imagine you're sitting in a train, passing this side, flash, flash you can see. It's impossible, and also the requirement was it needs to be invisible. Yeah, so that the train driver is not disturbed. That would be even worse, and all the people which are surrounding are not disturbed. That's why we said, okay, we will take infrared, and we have very good results with recognizing the things, the requests from the customer, also with these infrared pictures and a higher resolution. Yeah, of course we need lenses, because some cameras are more far away from the middle of the track. We have good experience, 2 to 8 meters is no problems if we have a lens. It also depends what you want to see. Also, of course, the speed is a thing in it, yeah. So we have standard C-mount lenses with a near-infrared bandpass filter to suppress ambient lights. That's very important. And we have a zoom from 6 millimeter to 35 millimeters, yeah, to focus on that what we want to see. Yeah, for the flashes, as I said, infrared, 850 nanometers. We take a small size flash, a mid-size flash, and a large size flash, also depend on what we want to see. For example, the camera which looks on top, it needs a very big one, yeah, to light the scene and to get the pictures in the quality we need. So that's also dependent on the requirements.
Yeah, so in the sense you would mix and match this depending on those requirements. Yeah.
Correct. We would mix this. They are flexible. Also, our video PC, it's possible to use different cameras. We could also use color cameras, yeah, which then are connected via the standard Ethernet. But at the moment, we decided to go with infrared to fulfill those requirements. Okay.
Yeah, Nick, we also brought some examples to show you that
very
this is.
What do we see in the end?
We have, for instance, we can also recognize what we said, USC numbers, as well as QR codes. And what's interesting, what many people don't know, is that behind some of those QR codes is an extensive information set already online available. So it means when we scan that, we can even access the online information and match it to the asset that passes by. So we already know who is the owner maybe, and other information. And it always is important, especially when we talk about condition-based maintenance, is always important when you have multiple measuring points in time, that you are always able to measure, to bring the data and the asset together, to know that the data is belonging to this asset. Yeah. And this is also what Thomas said earlier, when the train direction, because you want to know the orientation. The train is oriented in the wrong direction. Maybe the first time you looked at the wheel in the left front, and then the next time you're looking at the wheel of the right back. So it depends on the orientation. That's also a very important factor. Also, what we can see, what you see on the left side here is a top-line lock identification, and it's really important that for the customer, if it's closed, opened, or maybe not closed entirely. So you want to know that before it maybe leaves your yard, or also along the way. It can be a very important thing, and this is just one of the use cases where you say, okay, I need the camera on top to look on the side and find out what's happening here. Another way is here the information plate. So the information plate is located usually at the same position, and it contains a piece of paper where there is information, of course, on it. And in this case, the customer would like to know, is the paper in there or not? Because this has a relevance. And sometimes you think it's very easy, and sometimes it is really easy to spot certain things in a visual signal. In this case, we had some challenges in the beginning because also other parts of the train looked very similar, and our pattern recognition algorithm matched those positions. But now it works very well, and we also can then identify, is there in fact a paper in there or not? This was one of the use cases. Also very important, also for the future, is the wheel wear identifier, because we can use the standard cameras already to determine the wheel wear. How much do you still have? And the way we're doing that is, you see these 3 lines can be recognized by the image processor, and we have this. You see the colors and the 3 lines basically that we identify, and you can measure the points. What sometimes happens, unfortunately, is, and this can be through to glances, through to unusual wear down, can be that it is misinterpreted, that you see on the right lower point, and you may or may not see there's a black in the middle. There's the line where it should be, but it's recognized very low. So this would be a miss. And of course, the algorithm learns, and over time it gets better and better. So we can also determine that. And this information can be passed along to the maintenance yard already, for instance.
And we can also present mist, and a human could look at it and say, hey, yeah, it's okay, or it's not okay. So, yeah.
Exactly. With this printing to say we're labeling that as a mist, it should have been here. The algorithm is also capable of learning and making better predictions. Another thing is the stitched images. What you can see here are 2 stitched images of 2 trains.
Okay, so there's one at the top and the bottom, correct?
Exactly, the commuter train on the top, and the second one is in a cargo train. And what you can see on the cargo train is something that unfortunately many cargo trains have, is a graffiti.
Yep.
And sometimes it's even, in this case not, but sometimes it even is on the USC number. And the interesting thing here is that if you know the wagon series, so you know the USC numbers that should be in this train, and maybe you can't read a single USC number because there is a graffiti or something or dirt on it, the algorithm could potentially, and this is what we call fingerprinting, say like, okay, the missing USC number is this and that, so there's one train, one wagon missing, so it must be that. So you could label this wagon, and the next time the same graffiti is passing by, it's recognized as this or that USC
so you're
number.
almost saying it's a good thing, the graffiti, theoretically, in theory.
In theory, but in this case, it could be a feature, of course, to recognize. The stitched images are, of course, a series of a lot of images. You can also recognize this by the flashes in the top picture. You see a lot of these glances reflecting from the surface, and the algorithm detects how it can be stitched together, so you see the whole wide view of the train. And, customers have multiple times requested this feature because you get an untransformed picture of the whole train. If you would make a picture with your camera, with your phone, it would be very small in the ends and very big in the middle. And this is one way where you get an untransformed picture of the entire train.
I wouldn't know it was stitching unless you told me.
And the use case behind is that, for example, if you have a yard, that you get this picture when the train is or the wagon is going into the yard, and if there is some damage later, you can prove.
Right.
Listen, at that time, that was the status of the wagon. Here is the damage already, and it was not done in the yard. This is a very often discussion the customer has. That's why it's so important to discuss the things together with the customer.
So basically, those were the examples that we brought with us today.
Wonderful.
And I even brought some more questions.
Yeah, because I was going to get to that, because I think now that you've informed the audience, I think they'll have a much better understanding of how this works, and they'll be in a better position to answer your following questions, because they relate to the functioning, right?
Yeah, absolutely, because we think that there is a lot of different use cases, of course, in visual train analysis. And my questions to the audience would be how big you think is the potential for visual train analysis currently, because we already discussed the circumstances and that the environment is really ready for that. And are there a lot of existing needs that you already know for rolling stock detections? Another question would be, and I think this will be presented via Paul again, is what are your most important monitoring functions with VTA? So maybe you're already using a video system of some kind. We had one customer that is, for instance, very interested in such a solution because there is a human waiting at the entrance of a feeder line, and this human has an Excel sheet. Actually, you could imagine the train comes in, and he has to put in the Excel sheet if the train series is in the right way. Yeah? And you can imagine it's not a nice job to do that, and it is really something that calls for human error.
Right.
And with such a system, you can really support that process easily.
I have one of your, I have one of the results in. Do you believe that VTA is capable to increase the validity of existing wayside monitoring? Vast majority agrees. So that's a very good sign. Also like to point out we have a variety of people posting questions for later, so we do need to make some time for that. In fact, I think we can already get into some of the questions maybe, because there's been something on my mind, and I'm joined by Håkan Johansson from Sweden, who has the same question. When I go to Austria, I go skiing, it's snowing. Does that system, can it handle extreme weather conditions like snow, hailstorm, rain? Does it still work? Do you get the same quality images?
Can you say about that? Thomas?
Yes, we are doing a lot of pictures and with very high speed. So rain and snow, of course, influences the picture, but because we have a picture series of one wagon, we can choose, and usually it's not so dramatic. Of course, if you have fog, and you can't see with your eyes to the wagon, also the camera won't see. But the snow and rain conditions can be, it's not so critical for the VTA system.
Speaking of something critical, whenever pictures are involved, privacy law come into play. Should operators or people who use this worry about such things? Where are these images going? Is it sort of secured? What can you say about that?
You're speaking about, for instance, a passenger train where people sitting in there.
For example.
There's two ways. This is very serious, of course, and we had this question also in our company. And for us, there are two easy ways to do that. The first thing would be to just black out the windows. We can recognize with our pattern recognition exactly where the windows are, and we just black it out. The second way is to recognize faces and blur them out or black them out. So there are two ways of doing that, and our system is definitely capable of doing so.
Really? Oh, very interesting. We've seen a number of setups, and you say it really depends on the user case of what you need. This is a question that not a lot of companies go into, but what does it cost? And then how quick can you build such a thing? Can you give me any estimate or any idea?
Of course, this is always the start. How much does it cost? And the answer is very easy. It really depends on the use case. Because if you think about lower speeds, you need lower frequencies, lower recognition rates. You need less light because higher rates need also more light so that you get the right aperture for the imagery. So it means you need high quality and more premium products to do that. So it really depends on the use case. If you have a heavy haul transport that goes by 50 kilometers an hour or a high-speed train going by 200 kilometers an hour, it's a whole different hardware setup. The second part of my answer to that would be that we didn't explore all the use cases because there is indefinite numbers of use cases, of course. So the way I see it is that it really depends also if there is an unexplored use case, and we have to put in a lot of research to find the problem that the customer seeks. So this is the second part of maybe how much it costs.
But you mentioned high speed just now. Tarek Channel also asking, is there a speed limit? Can it capture like the fastest of trains, or is it bound to some limitations perhaps?
Yeah, there's of course boundaries for speed. You need different kind of cameras, different frame rates. At the moment, the cam we are using, for example, at our yard, is a camera which is capable of 50 frame rates per second, and we can go 30 to 60 to 70 kilometers. And if you need more speed, you need different cams and probably some more light. And it's not going in this, it's going in this. So when you really want to recognize a UIC number with 300 kilometers an hour, you would need a camera which is really, really expensive.
Right.
But it would be possible. A real diameter, from our point of view, is not possible at 300 kilometers and doesn't make sense. Yeah. So the more the speed grows, the more expensive it gets. Yeah, because also when you go with 250, you need another video PC for it because you have 2 lines, you have more data, and yeah. So the limitation is money. No. Also, that's something you have to have a look on what the customer needs are, and what can we say what is the best for viewing sets. So what requirements are really necessary and what is so expensive, and for what do you need the data?
Yeah, so we come back to that original. You can mix and match, and it also explains the difficulty, why it's so hard to put a price on it, because you can go to great lengths, essentially.
Yes, absolutely. And what we recommend, what we do is we engage into basically a consultative approach.
Right.
That we talk with the customer, what would you like to have? And if they say something like for high speeds, for instance, then we can explore with them, is there maybe a possibility that we find a location that's suitable for maybe a little bit lower speed, but then we can maybe save on the money side, save also on the complexity of technology.
And have more accuracy.
And have more accuracy. So this is something that we have to explore together. It's not an off-the-shelf product.
Yeah. It's good that you mentioned locations, because Mr. Sengupta from India, we do have a very international audience, thank you for joining. What of the scope of its applicability in underground metro systems? Is it, can it be installed underground, or is it strictly a system that you would install on the surface?
It can be installed also in underground. Actually, that's also what we found out. The sun is a problem for us.
Really?
If the sun is right in front and directly into the camp, that's not good. So before we start an installation or discuss with the customer, we make a simulation, also with the orientation where the sun stays and what time. And the darker it is, there's no sun, and our light gives us the light, and that's more dependent because we know which kind of light we have. Actually, in a tunnel, it would be more the dirt factor.
Right.
Yeah, which we then have to check how often we need to clean it. That's why we also put the cameras on the side, so that cleaning is possible. Yeah. But in a dark scenario, it's even better for us. Maybe you need more light, but we then have it in our hand how much light we put into the system.
Maybe I add to that in the current setup from our research facility that you have seen in the picture, we didn't have any problems with dirt. So we were very surprised that we didn't have to go there to clean on a regular basis, because somehow it's not as affected by that as we initially thought.
Not also in winter when there's perhaps more rain and
Not yet, so far.
The cameras are protected,
right.
And it's only a small spot where the cameras look through. Of course, if the dirt is on it, then of course somebody needs to clean, but it wasn't the case. Sure. Also in our cameras we use for PVS, cleaning is not such a thing for them.
You mentioned a few limitations. Are there any others? Because you talked about a lot of the things that the system can do. You said that the sunlight might be a limitation. Is there anything else that we need to consider, perhaps?
Yeah, we had, for example, requirements that the customer wanted to see an oil on top of a bumper or something like that. That's a limitation. Yeah.
Sounds complicated.
Any kind of liquid on top or is a problem. We can't detect it if there's really something, and even so, if we take the picture, it's difficult also for a human being to detect that. And then, of course, also with machine learning and artificial intelligence, this wouldn't be possible. That was one of the requirements. We said no, that's not possible with the system.
Yeah, clear. Another interesting question from Tarek. Once again, thank you, Tarek. For your application, should the track be straight, or can you also make pictures in a bend or on a curved piece of track?
It should be straight.
It should be straight.
Yeah. to get also for the stitching pictures, have the pictures to know in which angle we need to recalculate them. It should be a straight track.
Yeah. Another picture question, if I may. Liming C is asking about the type of cameras you use. Now, you showed a few. Maybe we should recast that in. Are those off-the-shelf cameras?
Yes.
It is. Yeah.
Right.
Those are off-the-shelf cameras that we use. Those are standard cameras. I believe if somebody has taken a screenshot of our presentation today and Googles that, you probably will find it. So it's pretty much off-the-shelf. But we didn't want to place the labels, everything.
You can't buy them if you go into electric stores, this kind of cameras, but you can buy them at the big shops. Sure. This was was very much in our focus to use standard cams, connected gig E-cams we are using, so that we can replace them if they are not available anymore, and to have a better selection of cameras.
And the reason for that is it's not our core expertise to come up with new cameras. There are brilliant solutions already available in the market. Where our experience comes in is then in the software. And there is where the magic then lastly happens.
Yeah. Excellent. More questions are coming in. Fabrizio Cortone is asking, you have the setup in Linz in Austria. I know it's under development and you're gearing up for the rollouts. So perhaps this question comes a bit too soon, but are there already installations, customer installation in operation?
Yeah, there's, of course, we use cameras for a long time right now. So as we have seen for the drag equipment detection as well as for the PVS, and also those cameras can be used for different applications. For instance, one potential use case is that a customer of open carriages would like to know if some of the transport's goods are shifting. Because this could be an indication for imbalanced loading. And this you can also photograph basically with the cameras that we already have. So the question is, if the question is, do we have already some yellow cabinets with cameras standing at customers, then the answer is no. But we do have camera systems already installed.
Okay. So if a customer comes with a certain request, let's imagine a scenario where there's a basic installation. Within which time frame will you be able to deliver that setup?
I would say that it really depends on the complexity of the problem the customer wants to solve. Because if there's, let's say, 2 months of clarification, what kinds of use cases the customer wants to explore. Of course, we have a lot of use cases already shown that and most of them we can already to some extent deliver. But there is, of course, as a customer, you want to have a specific use case, usually. And this is where I would say maybe the setup to have something in the track goes much faster than the software development that is maybe involved. So as we said, it is standard equipment. So the poles, the equipment, the connections, those are standard equipment that we can easily, right now, nothing is easy because of the worldwide supply chain disruptions. However, we hope that the standardization of these cameras allows us to bring the hardware very quickly where it's supposed to be. And it depends then on the use cases, how much time it takes until the problems are seemingly integrated in the customer processes. I'm
quickly checking the screen if questions are coming in. I have one, since there are none at the moment, but if you do, you're obviously very welcome to put more questions in the app. You mentioned that UIC number earlier and why that is important. Can you elaborate on that point and why the customers would want that?
This is a very good question, because this was one of the initial motivations why we went into VTA. In Europe, the RFID tags are not distributed yet to the extent that we would like to have it. And what this means is that it's not easy to allocate the data to the asset. So when you're measuring, for instance, an acoustic or a wheel impact detection and wheel impact and load detection data, and you cannot allocate it to the asset, it has no value for a condition-based maintenance regime, and also you cannot elaborate on a predictive maintenance regime. This is why this is very important. Another way of doing that is if you know the wagon series. But as we know, this is also not always the right in the right series. And the third possibility how to do that is, of course, by the use of a visual train analysis. And if you can read the USC number, you know not only in which direction the train is going or the orientation of the asset, you also know which the asset is, and then you can allocate the data. So it adds to the existing environment and enables, especially in heavy haul applications, where it's often difficult to place so much RFID text.
Yeah, very interesting. Questions are still coming in, so we're changing topic a little bit based on how they come in. You talked about the software learning, right? You had the example of the wheels. Is that a requirement for the system to evolve? Do you need these sort of misfires, if you will, from the camera to improve it?
Mm-hmm. Would you like to answer that?
Yes, for some of the requirements we need it, yeah, but most of the requirements we can do with the standard pattern matching algorithms. But of course, for the fingerprinting or for the rim thickness, we need the feedback also from a human being for the pattern recognition, but not for all the things, yeah. Also for the UIC number, if it's visible and not sprayed, we can recognize it quite good.
Mm-hmm. Yeah. Excellent. I'm going to, for the time's sake, assume right now that there's not going to be any questions, but I do like to hand the floor to you one more time to maybe add a final point on the functionalities or on the principles of the VTA, something you would like to close off with, perhaps, or something you want to underscore?
I would very much like to underscore the necessity of how a customer should approach VTA function. Yeah? If there is a problem that you want to solve, if there is a problem that you want to solve using a VTA, then please come to us, discuss that. We can do workshops together in order to explore these use cases and see what could be the best VTA setup to solve this particular problem. And then we can also give estimations of how long it would take, how much it would cost. So it's rather, this approach is better than drafting a tender, maybe, that is right from the start with a lot of question marks, where we then have to engage heavily during tender phases and a lot of stress to get the timeline straight in order to facilitate that. That would be very important for this kind of system.
Right.
Yeah, and we discover a lot of more potentials, also talking with customers. Yeah, for example, we just saw that we, with our cam, can see the banding of, of the track. Yeah, and we are now checking, hey, maybe we can see what's the load of the wagon,
really,
to estimate that. So there's a lot of more potentials in it, also using different cams. Yeah, we are thinking of using line cams and all this stuff to get other kind of images which fit to other kinds of requirements. So also with our standard setup we use, we try to get all the potential which is in the picture recognition work which can be done.
Our audience, by the way, did make use of the sort of fact that we're nearing the end, so they put in a few more questions. With your permission, I'm just going to pose them.
Go ahead.
Andy Bellington is asking, how confident would you be in recognizing hazardous material information through this system?
Hazardous material, so loaded, or not the sign, but the loading itself?
He will elaborate later, but for the time
Let's go for the signs.
For the sign, it's very good. So if we have this orange sign, I think it's in Europe, it's the standard. That's something we have for one of our customers in a yard where we need to recognize that. Yeah, otherwise it's not allowed to drive with these wagons in some areas in the yard. That is possible, very good. Yeah, and to recognize material on a train, it's problematic. That would be another requirement. We would need to take pictures and then check what we can do.
It involves the standard size.
Okay, perfect.
Standard sign is
easier.
Can very easily be
excellent. It seems that the images itself have also intrigued our audience. Janvik Kranenberg is asking, are the images made available in black and white eventually, are they also there in color, or do they really are they shot in black and white?
They are shot in black and white. With
Short answer.
infrared light, yeah, so they are not. If you need images in color, you would need visible light. That's the story. And that's a physical thing, yeah, that's possible. But you need really, you know it from photographs or from studios where you have where you need a lot of light to get these images in color.
Yeah, fair enough. I'm going to allow one more question.
Go ahead.
Let's see, Mr. Harshal Kulkarni, does your detector system get affected by electromagnetic interference or other cellular interference? That's an excellent question, by the way. Thank you.
Yes, we don't have problems with electromagnetic interference with the cams. We have, of course, and all our equipment is tested, yeah, with the standard tests, and of course, if you go with the biggest magnet on our case, there will be an effect, but all our material is tested, standardly tested, and we don't have any problems with that. Yeah.
Excellent. Thomas, Stefan, I'd like to thank you a great deal for joining us here today. It was excellent stuff, very interesting. Also, thank you our online audience. They were from all over the world. I saw people from Sweden, Portugal, France, in addition to the ones we already welcomed. Thank you all for joining. I would imagine that we can see you at InnoTrans. Perhaps that's a massive event, bigger than ever this year, I believe. So where we can find you, yes.
Yes. So
we need directions.
Absolutely, Nick. So everybody is, of course, invited also to see the VTA system firsthand at InnoTrans in Berlin, coming up on the 20th to 23rd of September this year. We are in Hall 21B, booth 150. I mean, our booth is huge this year. Railway systems is all over the place. However, compared to how big the InnoTrans will be this year, so InnoTrans is supposedly to be filled every hall that Berlin can offer. So Hall 21B, I'm hoping to see you there as well.
Gentlemen, thank you again. Thank you our online audience. Do join them at InnoTrans or visit our website realtek.com for more information about the system. Thank you so much for joining.
Thank you, Nick.
I believe we have another great video, right?
Yeah, I hope so. Let's see.
voestalpine. One step ahead.